Hello, great souls. Welcome back to my YouTube channel. This is Onami Jangeta, and it's good to be with you again. Today we'll be doing functions, but quadratic functions. So if you haven't subscribed on my channel, please do so. I would really appreciate that, and you so that you could join our family. All right, so today we'll be doing functions, quadratic functions. In the previous video we were doing the linear function. So if you haven't watched it, please go back and watch it. It's gonna be helpful to you. So today we're doing a quadratic function. Remember, I said in the previous video that a function is when there is an x value, there is also one y value. All right, if you have two y values in a function, it means that that is not really a function. Okay, so we have a quadratic function, which is also called a parabola. All right, so the reason why it is called a quadratic function is because it has two x intercepts. It has two x intercepts. All right, and also a quadratic function has two standard forms. The first one is y is equal to ax squared plus bx plus c, and the second one is y is equal to a into x minus p all squared plus q. All right, so I would like us to start with the first quadratic standard form. So in this one, you have your a controls the shape of a quadratic function. All right, how? Okay, if your a is positive or your a is greater than 0, it means that your graph will open upwards or will form a smiling emoji. That's a mnemonic we use for a positive a value in a quadratic form. It will be like this. Okay, so if it was an emoji, it was gonna be like this, and then there's eyes here. It's a happy graph. It forms a happy face. All right, okay, and then if a is negative or a is less than 0, it faces down. All right, so it will create an angry face, right? Angry, sad, angry. No, it's angry. Okay, so what you should know about a quadratic function, that it has a u shape. It has a u shape. Where should I write that? It has a u shape. All right, you're gonna see that as we explain all together. All right, so you have your b. We're still talking about a, now we're on b. You have your b. What does b do in a quadratic function? Okay, your b determines the position of the graph. The position of the graph. Okay, remember your original graph is like this of a quadratic function. Okay, let me do this. I'm gonna just draw a very small graph here. Okay, and then it will be like this. So if your b is negative, in a quadratic standard form, it means that your graph will shift to the left. Your graph will shift, it will shift to the right, will shift to the right, and vice versa. If your b is positive, your graph will shift, positive, sorry, will shift to the left. So this actually these actually give you a clue, so that you can see, you can easily see if you're sketching a wrong graph, okay, because you already know their functions. And then you have your c. Your c is your y-intercept. Remember, in y-intercept is a point where y cuts. Okay, so we are moving on to the second the second standard form, a into x minus p squared plus q. Okay, so your a also represents the shape, and then your p represents an x coordinate of a turning point, coordinate of a turning point, and then your q is your y coordinate of a turning point of a TP. Let me just call it that. Okay, I want you to take note of these, because you're gonna need them as we go along. All right, now let's move on to what we call as a turning point. What is a turning point? Okay, let's put another paper here. Turning point. Okay, you have your turning point. So your turning point is where the graph changes direction. Okay, it's where your graph changes direction. How? Here is how. Sorry about that. Okay, so this is your graph here. Okay, remember, this is your x, this is your y. Okay, let's say your graph is like this. Okay, it's facing downwards. It means your a is negative, your graph is angry. All right, this would be your turning point. Okay, this would be your turning point. This is where your graph is changing a direction, and it cuts the graph into two equal mirror sides, into two equal sides. All right, so this side here, from this point to this point, this side of the graph will be equal to the other side of this graph. Okay, so what about this line here? This line here is necessary in a quadratic function because it is called a line of symmetry. A line of symmetry. It's a line of symmetry. Okay, it's a line that cuts your turning point. Okay, so how do we find a turning point in a quadratic function? How do we find the turning point? Okay, let's start with the first standard form. Remember this one is equal to ax squared plus bx plus c. All right, so your x coordinate of a turning point will be equal to negative b over 2a. All right, negative b over 2a, the number that will be here and the number that will be here. All right, and then when you find that x coordinate, you substitute that x coordinate to the original equation. Okay, this equation, when you find it, you're looking for a turning point, right? So you found an x coordinate of a turning point, and then you have to substitute this x coordinate in the original equation to get y. All right, and then in this standard form, y is equal to x minus p squared plus q. All right, now I will need your clear attention. So remember, I said that this is a line of symmetry. Okay, it cuts your graph at x-axis. It's a line of symmetry because it cuts your graph at x-axis, okay, through the turning point. So here is your formula of line of symmetry. Okay, so it's here, y is equal to, okay, it says x minus p, this one is equal to 0. So what will happen to when you want to find the value of x, you will say x is equal to positive p. So what does this mean? It means that this p represents your x coordinate. Can you see that? This p represents your x coordinate, but in an opposite sign. Okay, what does this mean? It means that when you are seeing this equation, you should know that you are already given a coordinate of a turning point. Okay, so this will be your x coordinate of a turning point, and then this will be your y coordinate of a turning point in this standard form. But this x coordinate will change sign whenever you were given this p here. You will take it as your x coordinate of the turning point, but you will have to change its sign every time you are given it. But the q, you do not change the sign of the x coordinate of the y coordinate in q. All right, okay, so the reason why you do this, they will be asking you to calculate a line of symmetry. When they ask you to calculate the line of symmetry, you use this formula. So what will be the coordinate of the turning point at this instant? Okay, it will be your p. As you see, your p was negative here, so here it will be positive. Okay, and then your q. This will be your x coordinate. Remember, you always change the sign when you're given the standard form, and then they say give the coordinates of the turning point. You already know that p will be your x coordinate of your turning point and q will be y coordinates of the turning point, but p will have to change the sign every time. Okay, so now we move on to sketching the graph. So now we are sketching the parabola graph. Okay, hope you see my writing there. Okay, so we'll be sketching the graph of a parabola using the first standard form, which is, okay, whenever you are writing you are given an equation, first write a standard form so that everything should be clear to you. So we'll be using the first standard form, which is your y is equal to ax squared plus bx plus c. All right, and then you're required to sketch the graph of y is equal to, okay, which equation can I take? Y is equal to x squared minus 4x minus 5. All right, first things first, you determine the value of a. Okay, you note these things down first before you draw the graph. Actually, it's very important for you to do that, so that even if you don't sketch the correct graph, but they will mark the workings. All right, so now you see that this represents your a, this represents your a, this represents your b, and this represents your c. All right, so you see now that a is positive. Okay, what does that mean? It means that your graph will be happy. Your a is greater than 0. That means your graph will be like this. It will face up. Okay, right? And then what else that you should okay, and then what else that you should know? Okay, firstly and secondly, you should know your x-intercept. Remember in the previous video I told you that you will be doing this more often in functions. So for x-intercept, you let y equal to 0. Okay, so here is how you're trying to find your x-intercept, and you should expect your x-intercept to be 2. Remember I said at the beginning of the video that in a quadratic function you have 2 x-intercepts. So now y is equal to x squared minus 4x minus 5. All right, you're trying to find your x-intercept. That means you let y equal to 0, so it will be like this. 0 is equal to, okay, remember this is a quadratic, so that means you have to factorize using the steps of factorization, or if you don't find the points, that means you should go ahead and use a quadratic equation. So you open your brackets, 2 brackets. Okay, if your x is positive here, I mean your a is positive, that means you should put your x's here. X times x should give you x squared, and then you go exactly to the last term. Okay, the last term is 5. It's negative 5. So you will be trying to find the factors of 5. Okay, it's your 5 and 1. All right, so this 5 and 1 you should, okay, let me write that down first. 5 and 1. Okay, and then now you have to check the middle term. So this 5 and 1 should be added or subtracted in a manner that they give you a middle term. Okay, so you know that it should be negative here and positive here. Why negative here and positive here? Okay, first of all, a negative times a negative, it will give you, a negative times a positive will give you a negative. All right, remember that as you go on simplifying the quadratic, if you were to carry on to the steps, to the other steps, there would be a point whereby you will have to add or subtract the like terms. Okay, so you know that a negative and a positive, you have to choose a sign of the bigger number there. So the sign of the bigger number here is 5. All right, that's why it gives you the 4 upward. Okay, so now you have your roots. These are called roots. Okay, and then it will be 0. You carry on. Remember, you're looking for an x-intercept. You're looking for x-intercept. You're not done yet. So is x minus 5 or 0 is equal to x plus 1. Okay, and then when you transpose this 5, it will be 5 is equal to, this is your first coordinate, and this is your second coordinate. All right, so now you move on to the y-intercept. The y-intercept. Remember, I told you that in this standard form, your y-intercept should be equal to c. Should be equal to, should be equal to c. But you have to calculate that. The examiner or the marker should see that you know how we find that c. So you know that when you're finding a y-intercept, okay, you let x equal to 0. All right, where you see x, you put 0. So y is equal to x squared minus 4x minus 5. Y is equal to 0 squared minus 4, 0 minus 5. And then these will give you zeros, and then your y will be negative 5. All right, okay, what else? Your turning point. It's very important, your turning point. Now you have to find your turning point. Remember, I told you that turning point. I told you that in order for you to find the turning point of a parabola, you have to use the formula x is equal to negative b minus 2a. All right, and then you go back to your equation. Which one is b? This is b, right? Remember, the negative is for the formula, and this negative is for b. Negative 4 over 2. Which one is a? Here is a. A is equal to 1. All right, and then a negative times a negative is a positive, so it's positive 4 over 2. Okay, positive 4 over 2, which will give you 2. All right, and then I said that you take an x value and substitute it back to the original formula to get the y values. Okay, to get the y value. All right, substitute x into the equation to get y, right? So y is equal to x squared minus 4x minus 5. All right, so y is equal to 2 squared minus 4 into 2 minus 5. Okay, you can punch that using your calculator, or you can just do it. 2 squared will give you 4. 4 minus 8. 4 minus 8, it's minus 4 again. Minus 4 minus 5, that's minus 9. But you can check that using your calculator, right? Squared minus 4 into 2 minus 5. Okay, you get minus 9. Y is equal to minus 9. So your turning point coordinates will be 2 and minus 9. All right, and you sketch the graph now. So remember, before you sketch the graph, grade 12s, you check the coast. Okay, what do I mean by that? You check if which side are you gonna need the most. Okay, here let's check. Okay, I'm gonna need the y, the higher coordinate for y will be -9 and -5. All right, and then for x it's going to be 5 and 1. Okay, so what do you do when you sketch the graph grade 12s? You measure the spaces in between the points in your coordinate, in your Cartesian plane. All right, every space should be equal like this, right? It depends if the distance between the spaces is 1 millimeter, but you should measure that. But what I'm going to do to save time, I'm just gonna put the exact values that I need. Okay, I'm gonna put the exact values that I need, but for you measure, you try to make your graph to be as accurate as possible. Okay, remember, this is your x, this is your y. So now you plot the points first. Remember, your x, you have your +5 and your -1. Okay, I'm gonna assume that +5 is around here, 5 and 1, and -1 is here. Okay, what else? You already know that your graph will be happy. Okay, what else? Your turning point is 2 and -9. Okay, I'm gonna assume that your -9 is here, and I'm gonna assume that probably your 2 is here. It won't be as accurate as it should be, but remember, you're supposed to make it accurate. So this is your coordinates of the turning point. Okay, this is your coordinate of the turning point. Your turning point should be here. Okay, what else? Your y-intercept. Your x is 0, but your y is -5. Okay, I'm gonna assume that your -5 is here, -5 for y. All right, and then you join your points. Let me use a different color to join the points. Remember, your graph is facing up. That means it is happy. So your first point is here, your second point is here, and this is other point, another point. So I'm gonna try by all means to do this, but okay, I think it's coming along. It's coming along, and then this is your turning point. Your graph changes direction. Your graph turned. Okay, and then you join all the way up, all the way up. Okay, so this is how you sketch the graph. The domain and the range. The domain and the range. Remember, I told you in the previous video that a domain are your possible x values, right? And then here are your possible y values. Okay, for the domain in this graph, it will be x is an element of real numbers. What does this mean? It means that your x are from a -infinity to a +infinity. Remember, you see these are your x values, and they are going up. The arrows means that they keep on going up and up and up until an infinity, and then your y here will be slightly different. Y is an element of your graph turns here, So this is where your graph starts actually. So it will be the coordinate of TP, which is your -9 to infinity, right? To infinity. Okay, right. This is how you get your domain and your range. Okay. Okay, and now you will be required to sketch a graph in this vertex format. Okay, let's say you are given an equation like this: -2x plus 1 squared plus 4. Okay, and then they say sketch the graph. Remember, you follow the rules. I would say the rules. You follow the rules that I have just given you when you're using that equation, which says y is equal to x squared plus bx plus c. It's the same thing even here. You first check your a value, and you see that your a is negative. It's less than 0. That means your graph is angry. It's gonna face downward. Okay, so and then what else? This is number 1. Number 2, you find your x and y intercept. Let's start with x intercept. So you find your x intercept. You know that when finding an x intercept, you let y equal to 0. Okay, so and what happens after that? You write your formula as it is: x plus 1 squared plus 4, and then 0. Where you see y, you put 0. -2 into x plus 1 squared plus 4. And then what's the next step? You transpose this +4 here, because we're trying to find x actually. So, and even here you should expect that your x, you should expect to get 2 x intercepts. All right, so it's going to be -4 is equal to -2 x plus 1 squared. Okay, you can divide by -2 by -2, and then here you got +2, sorry, +2, and then these cancel each other out, and then you are left with x plus 1 squared. And then you square both sides. Okay, remember, when squaring both sides, your square should give you a positive and a negative value. So this is be your plus or minus square root of 2. Okay, so let's start with a positive. Square root of 2 is equal to x plus 1, or positive 2 will be equal to x, -2 because of x plus 1. And then what do? You transpose +2 minus 1 is equal to x, or negative square root 2 minus 1 will be equal to x. Okay, square root 2 minus 1, remember 1 is outside. Okay, it's gonna be -1 plus root 2 is equal to x, or okay, or -1 minus square root 2 is equal to x, and this will be -2,4, 1 is equal to x, or -1 plus square root 2, 0,4, 4 will be equal to your x. 0,41 will be equal to x. These are your x intercepts. You have to plot them on the graph. Okay, so now let's find y intercept. You let x equal to 0. I'm sure you already know your y-intercept, or you don't know. Okay, let's find your y-intercepts. So y is equal to minus 2 into x plus 1 squared plus 4. Okay, so y is equal to minus 2 into 0 plus 1 squared plus 4. All right, so y, what is y, the value of y? So it's minus 2. Okay, you can just use the calculator, or you can just say 0 plus 1 is 1, so 1 squared is 1. So 1 times negative 2, it's minus 2 plus 4. Okay, you can confirm that. Okay, so y is equal to 2. All right. Okay, so you do know your x-intercept, you do know your y-intercept. Okay, take this space here. Now you have to find the turning point. Remember, I said that your turning point, okay, my camera though. Remember, I said that your turning point will be this value, but in an opposite sign, and this one. So here, your turning point, your x-coordinate of turning point, it's minus 1 plus 4. All right. Okay, so that's your coordinates of your turning point. All right, so sometimes they will ask you to give the coordinate of the turning point by completing a square. All right, by completing a square. Okay, so I'm gonna do a video for that. Okay, now you can sketch your graph. Now you can sketch your graph. I'm choosing to sketch it here because everything is here, but I have a small paper. Remember, I said that when you're sketching the graph, always make sure that it's as accurate as possible. Okay, so you have your x-intercept, which is your first one is 0, 4, which is 0, like basically, and then your negative, the other one is negative 2, 4. If you round that to a nearest whole number, it will give you a negative 2 actually. So I will assume that negative 2 is here. All right, and then what about the turning point? What about the turning point? So your y value for the turning point is 4. I'm gonna assume that 4 is here, and then I'm gonna assume that negative 1 is here, right? So they will meet here. Okay, so this is your first point, second point, and then you join the points. You join the points. I'm gonna use a different I'm gonna use a different color. So here is your here is your graph, and then you label your graph. Y is equal to negative 2 into x plus 1 squared plus 4. Right, you can also indicate the axis of symmetry to show the teacher that you know what you're doing. Okay, all right, and then there is your complete graph. All right, so yeah, I hope you understand. I hope the lesson was helpful to you. Please remember to subscribe, share, and like the video. Okay, we have to find an equation of a parabola. Okay, so I don't want you to worry too much in this section, because when they ask you to find an equation of a parabola, they should give you something. So it's whether they're going to give you the roots and the point, or they're going to give you the turning point and the point. All right, so in this they gave you roots. Okay, what's roots? Roots are your x, just like they indicated here, that x is equal to 2 and x is equal to -3. All right, so there is a formula that you use to substitute these roots. The formula for substituting roots is y is equal to a into x minus x1, x minus x2. Remember, this x1 and x2 are your roots. Okay, so what happens next? Okay, so you're gonna substitute the point together with the roots. Let's start with this point. This point has your x value and your y value. That means your y will be 6, -6. So it's going to be -6. We are trying to find the value of a. So whenever you are given a root and a point, always find a value of a first, and then everything is going to be easy for you after you have done that. So it's -6 is equal to 1. I mean a, because we're trying to find the value of a, and then we substitute the x here. Remember, I said that x1 and x2 are your roots, so it's going to be 0 minus the first root is 2 into 0 again, minus of minus. Remember, the minus is for the formula, and the other root is negative as well, so it's going to be minus of -3, so it's negative b. I mean, it's -6, sorry, a, into -2 and 3. Okay, so -6 is equal to -6a divided by -6 divided by -6. These cancel each other out, and your 1 is equal to a. All right, now you have found the value of a, and then you go back to the formula and substitute a. So y is equal to, remember, our standard form is equal to ax squared plus bx plus c. All right, so you already find the value of a. I mean, it's going to be x squared plus bx plus c. All right, and then how do you find b and c? You go back to your formula. Y is equal to, you already have your a, which is your 1, so we don't write 1. Okay, and x minus your roots, you substitute your roots again, minus 2 x plus 3, right? Plus 3, it's a plus. Negative times a negative, it's a positive. Okay, and then you expand, and then, okay, it's x times x, which is x squared, x times 3 plus 3x, negative 2 times x, negative 2x, negative 2 times 3, it's negative 6. All right, y is equal to x squared plus x. Remember, this unlike signs, we take the sign of the, we subtract and take the sign of the bigger number. All right, minus 6. So this is your equation. All right, you see how much this equation helps. You don't need much, it just comes out unexpectedly. Okay, this is your value of a, and then this is your value of b, and then this is your value of c. All right, okay. So now, what if you are given a turning point and a point, and then they ask you to find an equation of a parabola? What do you do? Okay, I always advise my students to use in this case, when you are given a turning point, I always advise my students to use a vertex standard form. Remember a vertex standard form in my previous video, or a standard form like this: y is equal to a into x minus p squared plus q. All right, I always advise my students to start with this, and then everything will flow. Okay, so here is how you do this. Remember, I told you that this p is your x coordinate of your turning point, and then this q is your y coordinate of your turning point. But this p changes the sign when you are putting it in point 4. How I told you how it changes the sign from the previous video. So here is how you do it now. So you are already given your turning point, right? That means you take the turning point and substitute it in this equation, and then you substitute the point also to find the value of a. Okay, so here is how we do it. Y is equal to a, we don't have a, into x. We do have the coordinate. I said this p is the x coordinate of the turning point, and then this q is the y coordinate of the turning point. So p here is negative, so it's positive, so it's going to be negative 1 squared, and then q doesn't change the sign. All right, so it's going to be minus 4. Okay, and then what happens? Okay, here you substituted the turning point, and then what happens now? You substitute the point 3 and 0. Okay, and then here it was 1 and negative 4. Okay, so you substitute the point in this equation now, so it's going to be y, point y, so it's going to be 0 here is equal to a into x is 3 minus 1 squared minus 4. All right, 0 is equal to 3 minus 1. 3 minus 1 is 2, and 2 squared is 4. So it's going to be 4a here minus 4. And then you transpose this 4 to this side. It's going to be 4 is equal to 4a divided by 4 divided by 4. And then your a is equal to 1. All right. Now that you have found the value of a, everything becomes easy when you find the value of a. So every time you are required to find an equation of a parabola, always start with finding the value of a. All right, so you come back to your equation, your equation here, and you replace the value of a. It's going to be y is equal to 1 into x minus 1 squared minus 4. Right, and guess what? You already got your equation in a vertex form. What if now you want to find an equation, you want this equation to be in a quadratic form? Then what you do now, you expand, and you will see what happens when you expand. Okay, so y is equal to, this is x minus 1, x minus 1. All right, this means that you have to repeat what is inside. Okay, minus 4, y is equal to x squared minus x plus 1 minus 4, y is equal to x squared minus 2x plus 1 minus 4, and then your final answer is x squared minus 2x minus 3. This is your equation, all right, of a parabola. Remember, what you did was you're given a turning point, you substituted a turning point in the equation, and you found the value of a. And then after finding out the value of a, you go back to this equation, because already this is your original of the equation. These points are your original of the equation, and then you substitute back to it, you find the value of a, and then after finding the value of a, you go back and substitute the value of a, and then your equation comes out unexpectedly. So if they want the equation in quadratic format, you expand this, and then it will come out as a quadratic format. This is your a, this is your b, and this is your c. Okay, and sometimes they will ask you also to convert this equation quadratic form into this form. Okay, I will teach you how in the next video. So thank you for watching. Please do not forget to subscribe. That is very important. Please do not forget to subscribe and join us every day as we will be learning throughout the year.